Okay, let's see if we can stop that. Let's let's go then. I start with the fundraiser. Can give us some money to carry on.
Hello, everyone. I'm David D. Hilster, president of the John Chappell Natural Philosophy Society. During the past 2 years, we have used annual fundraising drives in order to keep our organization's presence alive and well on the internet. Both years we have been successful in that the monies collected have been enough to keep us afloat. This year is our third annual online fundraiser, and once again we are counting on your support. But first, I want to thank everyone who pays their annual memberships through our automatic online system. Your support is vital and provides us with important funds to keep the CMPS afloat. Hopefully, as we continue to grow, we will be gaining more and more automatic memberships so that these fundraising events won't be necessary. But we are not quite there yet. This year, we will be implementing several changes to our online system. Several to save money and lower our annual expenses, and another to better our discussion platform. First, we will be moving our websites and databases to another server that has graciously volunteered to host us at a much reduced rate. It currently costs us $1,400 a year for our dedicated server, given that we need complete control over our own software. The new server will give us and allow us that control, but only for $250 a year. Second, we will be moving away from BuddyPress, which is a Facebook-like plugin for WordPress, to using Discourse. BuddyPress was an interesting experiment, but the upkeep of the plugin and its general design don't really fit what we need. What we need is a robust and well-accepted discussion forum, and that is why we'll be moving our online discussions to Discourse. It costs $20 a month, which is half the price of BuddyPress. I think those currently active in our online discussions will find this new platform much more enjoyable and functional. Third, we are moving to a free version of Overleaf, which eliminates a $33 monthly fee. Overleaf was useful for us when we were publishing our own proceedings for conferences, but that is no longer needed. Our goal this year is $2,000, and I hope we can reach that goal. Whatever amount you can donate, it is greatly appreciated and needed. Your membership and donations are vital to keeping our online community of critical thinkers alive and well. To donate, go to fund.naturalphilosophy.org. That is fund, F-U-N-D.naturalphilosophy.org. Thank you, and keep up the amazing work that is driving science forward.
So, hello. Welcome to another John Chappell Natural Philosophy session on relativity, onto my favourite subject, complaining about Einstein's relativity. And this time I'm going to complain about relativity from metaphysics. So, getting into it now. On to the next slide. Okay. So the metaphysics of Einstein's relativity is not taught to physics students. And there's a lot of things that are not taught to physics students. A lot of things are omitted from their education. And I have to go to artificial intelligence to help me out, to give me the information from what is being emitted from relativity tech, because you read a relativity text and they won't talk about the metaphysics side of things. So AI, artificial intelligence, is useful for giving this information, which is a missed out. And so presumably the main reason is omitted is because physics students are being taught physics, with metaphysics as not being deemed physics, and hence omitted. So the first thing I need to do is explain what metaphysics is. So according to Google AI, it's this. So hold on a minute, I'll make the screen bigger. And for me, that is metaphysics is a branch of philosophy that explores fundamental questions about reality, existence, and knowledge. It investigates the nature of being, the fundamental constitutions of the universe, and the relationship between the physical and the non-physical. And the key aspects of metaphysics are the study of reality. And metaphysics seeks to understand the nature of what exists, including physical objects, abstract concepts, and the universe itself. And so metaphysics does deal with the physical, but it deals with a lot more things as well, such as the non-physical. And so it then starts straying away from physics, and hence why physicists may not want to deal with it. But really, the part of metaphysics that deals with physics, students of physics really should be made aware of. And that's what I'm complaining about in this session. So Google AI, artificial intelligence, goes on to say fundamental principles. It examines the most basic principles and assumptions that underpin our understanding of reality, such as the nature of time, space, causation, and possibility. And so that's Einstein things there. Einstein with his relativity, he's dealing with the nature of time, space, and so forth. And it also goes on to deal beyond the physical. Metaphysics often delves into concepts that go beyond the realm of observable phenomenon and our immediate sensory experience, such as the existence of a soul, the nature of consciousness, or the meaning of existence. It also deals with the nature of things and method of trying to understand things. Metaphysics is closely related to ontology, the study of being, and the study of knowledge. So the physics bit of metaphysics is really the important thing that physicists should be dealing with, but they don't deal with it. They omit it from their education. So the key word is meta, which means beyond. And so it's beyond physics. And so, it's beyond physics, it's therefore not physics. So let's ignore it, think many physicists. But actually, metaphysics does deal with the things that physicists are dealing with in some of the issues, such as time, space, and so forth, which is brought in by Einstein's relativity. So it's annoying that it's missed out because it's about physics comprehension. And I asked AI why it is omitted. So it says, AI says this: physics students often aren't taught the metaphysical implication of Einstein's relativity, such as the nature of time, simultaneity, or determinism, for a few key reasons rooted in how science is practiced and taught. So thing I note there straight away that you've got Einstein's relativity, and they're not dealing with the metaphysics of Einstein's relativity when they're teaching physics students. So they're giving them a very shortened down version. They're omitting sort of like useful information, which they should at least be made partially aware of. So number one is physics prioritizes empirical and mathematical foundations. Physics, especially in education, emphasizes predictive power, equations that describe and predict behavior, experimental verification, what can be measured or falsified, operational definitions, concepts defined by how they are measured, e.g. time is what a clock reads, and that idea that time is just what a clock reads, well, I could start arguing that doesn't really make sense. But I think Einstein said, that's how Einstein said what time is defined as when he was asked what is time. Anyway, moving on. Metaphysics, on the other hand, asks questions like, What is time really? Question mark. Do past and future exist equally? And that comes into Einstein's relativity in the idea of a block universe? Question mark. Is the flow of time an illusion? Question mark. So all these things are in Einstein's relativity. Problem of what is time really? And I think Nick Percival has dealt a lot with that issue. And these are important, but not direct. So they're seen as philosophical within the standard curriculum. So what they're basically doing is when they're teaching physics students, they're missing out the philosophical problems. And that's when they're teaching physics. They think when they teach physics, we can miss out the philosophical problems, because they're then deeming physics is not philosophy, which is sort of like nonsense. Next one is the to pedagogical focus. That's about teaching things and tools, not interpretations. Students are first trained to solve problems, to calculate time dilation, length contraction, Lorentz transformations, etc., not to interpret what these mean about reality. So the focus is a large extent just on manipulating some mathematics, and they're not going into trying to understand what that mathematics is supposed to mean. And instructors often avoid metaphysical debates, so students don't get bogged down before mastering the core formalism. So basically, the focus is on, we can do a lot of mathematical manipulation. This is the maths of Einstein's relativity. But what that maths means, we're not going to go into that, because you can end up in debates where students are sort of like arguing over, well, if they did it, they would be arguing over what exactly that maths is supposed to mean. And they don't want an open debate on the subject. They just want to teach students things and not have the students question anything. And so that's my note there. That's interesting. In my view, wants to avoid debates about metaphysics because students would point out what is being taught does not make sense. Instead, students are just asked to accept what they're being taught, i.e. told not to use critical thinking on what they're being taught. And a large focus from what David de Hilster has been saying, that there should be critical thinking, but that's something that when they're teaching Einstein's relativity, they want to miss out. They don't want students to start suddenly critically thinking about Einstein's relativity, because that would, as what AI says, would get them bogged down. Right. The third issue is separation between physics and philosophy. Since the early 20th century, physics and philosophy have diverged. Einstein himself was deeply philosophical, but modern physics education rarely includes philosophy of science unless students seek it out. And when by that it would be, they would have to do a philosophy of science course, because it wouldn't be normally be included in the curriculum for a physics education. If you're doing physics, it would, the philosophy side of it would be outside of a normal physics course. So they've split the philosophy from the physics which they're teaching the students. And it says this is partly due to the increase in specialization of academic fields and the view that metaphysical interpretations are subjective or speculative, while physics must remain objective and falsifiable. Well, my complaint about that would be, well, they should be at least be made aware of the different metaphysical interpretations for the physics they're being taught. But no, they're just going to miss all that out. They don't want the students to suddenly realize, oh, we're being taught this interpretation, but actually you could be start looking at things, what we're doing, in a different way. They don't want students to do that. They just want the students to not have critical thinking. So the fourth issue is controversy and lack of consensus. There is no universally accepted interpretation of the metaphysics of relativity. Some physicists endorse the block universe idea. Others prefer what's called presentism or relational views of time. Because of this, textbooks often sidestep metaphysical commitments to remain neutral and focus on consensus views. My point on this is, in other words, metaphysics is voided because not agreed upon. And so that's interesting. That is sort of like, wow, you're a physics student, and suddenly they're going to teach you this physics of Einstein's relativity, and they're going to omit mentioning that there's lots of things that they're being taught which are not even agreed upon by the physicists. The physicists have all got different points of view on what they're being taught. And, we're not going to tell the students that. So that's another complaint for me on that issue. And it's, once again, it's sort of like, we don't want the students to have critical thinking upon what they're being taught. We don't want the students to be aware there's a lot of things that are not agreed upon in relativity. Fifth issue from AI points out is the time constraints and curriculum design. Undergraduate physics programs are packed with mathematics, classical mechanics, quantum mechanics, electrodynamics, thermodynamics, and more. There's simply little room for deep philosophical inquiry, even though it's arguably vital for deeper understanding. In my view, that's all just excuses. Metaphysics not even talked about a little bit to make students aware of the subject. Suddenly, you're going to miss out a vast amount of information by pretending there's not enough time to deal with it. And, we haven't got enough time to deal with it. We haven't even got time to even briefly mention that it's a vast subject, which we're not even having time to tell you. We're not even going to mention that that's what we got. So they omit it all. And so once again, it's sort of like, we're dumbing everything down for the poor little student. And they don't want them to have a deep philosophical inquiry upon what they're being taught. So they don't want the students to start arguing about things. AI points out there are some physicists that pursue the metaphysical issue. I think that's only a very few. Before moving on to metaphysics of Einstein's relativity, I asked what was the metaphysics of Newtonian physics. And so that's a good background. Let's start with Newton. See what was the metaphysics before Einstein's relativity changed things. And so this is what the AI says. It says the metaphysics of Newtonian physics refers to the underlying philosophical assumptions about reality that Newtonian mechanics rests upon. These assumptions are not derived from experiment, but are presupposed in order to interpret and apply the mathematical and empirical structure of Newtonian physics. So you've got to assume a lot of things before doing Newtonian physics. You can start doing the mathematics and so forth, but you've got to assume a lot of things before actually doing that. And here are the key metaphysical pillars of Newtonian physics. Number one, absolute space and time. Absolute space exists independently of the objects within it. It provides a fixed, unchanging reference frame. Example, even if all matter vanished, space still would be there. And absolute time flows uniformly and independently of events or observers. And this sort of like relevant quote from Newton: absolute, true, and mathematical time of itself and from its own nature flows equally without relation to anything external. So this is the metaphysics of Newtonian physics. You've got to accept this sort of metaphysics before you even do the mathematics of Newton, because this metaphysics is upon which the interpretation of the mathematics rests. Now, one of my complaints here is that Newton did deal with relative space and time, but AI wants to portray Newton as only dealing with absolute space and absolute time, but I'm going to pass on that issue. Next thing from Newton is determinism and causal structure. The world is strictly deterministic given the positions and velocities of all particles at one time. Their future and past is fully determined by Newton's laws. This implies a causal order in which events follow causes in time. And the implication is that the universe is like a clockwork mechanism. So the whole universe, in this interpretation, is a clock. And so presumably you would need somebody to make that clock, and that's what would bring God into it. So God would be the clockmaker in this sort of universe, this sort of metaphysical interpretation. And next one is issue 3, substantialism. Space and time as substances, not just relations between objects. Newtonian physics treats space and time as real entities that exist independently of matter. This view is challenged by Leibniz, who held a relational view. Space and time are merely relations between physical things, not entities in their own right. And all that, I think, is arguable, but let's pass on that as well. I'm only just pointing out what the metaphysics of Newtonian physics is. And number 4 issue for Newtonian physics is persistence and identity over time. Objects have well-defined trajectories and identities as they move through absolute space and time. Their properties, which are mass, position, momentum, and so forth, evolve continuously and deterministically. Implication: there is a clear metaphysical distinction between an object and its motion, which takes place in the background of space and time. And number 5 is objective reality of forces. Forces like gravity are considered real physical causes of motion. Newton spoke of action at a distance where one body can exert force on another without contact, and sort of that would be the gravitational. As an example, would be the gravitational attraction between the Earth and the Moon. This was a controversial idea and remained metaphysically puzzling even to Newton himself, who admitted he did not frame hypotheses about the mechanism of gravity. And my point on that was supposedly solved later by thinking of force in terms of a field. So you have a gravitational force field, etc. Issue 6 is the material substances and mechanism. Matter consists of discrete, solid, extended body, and Newton called that corpuscles, which obey mechanical laws. All interactions are ultimately explainable in terms of motion, contact forces, or action at a distance. Implication: nature of the machine. Oh, hold on a minute, I'll just check things. Okay, I hope I'm right. Carrying on. Implication: nature of the machine, and can be fully described with mathematical laws governing particles in motion. And so it summarizes it as the metaphysics of Newtonian physics is a realistic, mechanicalistic, and deterministic framework involving absolute space and time as a static stage, matter as a substance, movement under real forces, time as the universal, evenly flowing quantity, causality as temporary, ordered, and deterministic. So next thing I did is so I asked, did the metaphysics of Einstein's relativity look nonsense from the perspective of Newtonian metaphysics? And AI admitted yes, it did, thus highlighting the problem many statisticians have with Einstein's relativity. If we're going by the metaphysics of Newton, then Einstein metaphysics is nonsense. No wonder metaphysics is missed out from being taught to physics students. If you've taught physics students Newtonian physics and they've adopted a point of view based upon Newtonian metaphysics, then when they're suddenly faced with Einstein's relativity, you're not pointing out to them the metaphysics has changed, and suddenly they're going, well, what's being taught now doesn't fit in with my metaphysics and therefore must be nonsense. And so AI says, yes, it's admitting that Einsteinian metaphysics looks nonsense from the point of view if you're going by Newtonian metaphysics. And it says, yes, and you are not alone in thinking from the standpoint of Newtonian metaphysics, the metaphysical picture of Einstein's relativity can indeed appear nonsensical, incoherent, or even absurd. This reaction is historically and philosophically important. Let's break down why relativity looks metaphysically nonsensical to someone grounded in Newtonian metaphysics. I'll just have a little drink. So the first thing that AI points out is there's a loss of absolute time. The Newtonian view is time is universal, flows equally everywhere, and defines a clear global present. There is one now for the whole universe. And the Einsteinian view is time is relative to the observer's motion. Events that are simultaneous in one frame are not in another frame. There's no universal now. So that's the switch in metaphysics on this issue, from the metaphysics of Newtonian physics to the metaphysics of the Einsteinian view. So from the Newtonian perspective, it's how can something be real for one observer and not for another, question mark. If two events happen, how can it be undetermined whether they were simultaneous, question mark. Time is supposed to be the bedrock of causality. This seems to undermine objective reality, and so hence does not make sense. So from the metaphysics of Newtonian, the Einsteinian metaphysics does not make sense. Next issue is space-time replacing time and so in the Newtonian view, time flows independently of space. Space and time are distinct entities. And the Einsteinian view is space and time are part of a single geometric continuum. Motion through space affects passage of time. Time is not universal. So from the Newtonian point of view, it's this change to the Einsteinian view is time is a place. It shouldn't be fused with space like a direction. If you treat time as geometry, you destroy the flow, the succession events, and the possibility of change itself. This replaces becoming with being, leading to a frozen universe which contradicts our lived experience. So once again, from the Newtonian metaphysics, the Einsteinian metaphysics makes no sense on this issue. On the third issue, it's the block universe idea versus presentism. And so the Newtonian view is only the present is real. That's presentism. Past is gone, future is not yet. But the relativistic view is all of space-time exists equally. The past, present, and future are all there. So this change in metaphysics on that is from Newton's or common sense view. It's interesting to say that it's a common sense point of view. So the Newtonian metaphysics point of view is common sense. And it says, from that point of view, how can the future already exist if we haven't chosen it? Question mark. If all of time exists equally, where is change, freedom, decision, or growth? Question mark. And it seems to annihilate the meaning of causation and experience and agency. So once again, on this third issue, the metaphysics of Einsteinian view does not make sense from the Newtonian metaphysics. Issue 4 is there's no preferred reference frame. And so from the Newtonian view, there is a true frame of rest, which is called absolute space. Motion is measurable relative to this frame. However, from the Einsteinian view, no frame is preferred. All motion is relative. Even acceleration can be seen as relative in general relativity. And I find that bit about general relativity difficult to understand about the acceleration, but I pass on that. Anyway, from Newton's metaphysical point of view, this changed the Einsteinian point of view. Einstein metaphysics point of view is that this makes nonsense of cause and effect. How can a rotating bucket, and that's one of Newton's famous thought experiments, have real effects if rotation is only relative? Question mark. Einstein's answer involves curved space-time, an alien concept from Newton's metaphysics. So Einstein's metaphysics brings in this idea of curved space-time, which from the Newtonian metaphysics is complete nonsense. Issue 5 is gravity without a force, and that's from a Newtonian metaphysics point of view. Gravity is a force acting at a distance between masses. This force is real and measurable, while the Einsteinian metaphysics point of view is gravity is the curvature of space-time. Objects follow geocentrics, no force is pulling them. And so from the Newton point of view, Newton's metaphysics point of view on the change in this metaphysics, that's not an explanation, it's just geometry. How can curves make planets fall? Question mark. The metaphysical role of force has been replaced by pure geometry, which seems like a category error from Newtonian logic. So not only does Einsteinian metaphysics makes no sense from Newtonian metaphysics, from the Newtonian point of view, what Einstein's relativity is doing is making logical errors, and this is being emitted by the AI. And so AI says, gives a summary of why it looks nonsensical. Number one, relativity requires a different metaphysical framework. It doesn't just modify Newtonian metaphysics, it overthrows it. So that's one of the big issues here. If you suddenly being taught Einstein's relativity, you are going into a completely different metaphysics than what you may have been taught, from which you may have started to believe in from Newtonian physics. In Newtonian physics, they don't teach you go into the metaphysics issue, and that's something else they should be telling you. But from the Newtonian metaphysics, that's what's behind the Newtonian physics. Suddenly you are changing to a completely different metaphysics, and that change does not make any sense. And sort of like it doesn't just modify Newtonian metaphysics, it overthrows it completely. Second issue, Newtonian metaphysics is deeply embedded in common sense and our everyday experience of the world. So everybody from the early age, well, most of us, when I say everybody, most of us are deeply following a Newtonian metaphysics point of view, and suddenly you're being asked to completely throw that away if you want to believe in Einstein's relativity. Third issue, Einstein's relativity violates core ontological and epistemological assumptions: objective simultaneity, temporal flow, absolute structure of space, and causal clarity. From a Newtonian stance, relativity appears metaphysically incoherent. How can reality depend on an observer? And epistemologically unstable. What is really happening? So you don't even know what's supposed to be going on with the metaphysics of the Einsteinian point of view. So what's going on with it is sort of like doesn't even make any sense. And next one is morally or existentially unsettling. If the future exists, what happens to free will? So it doesn't make any sense whatsoever. And so AI leaps in to defend Einsteinian metaphysics. It tries to support the mainstream point of view about things, and so it then says, but that doesn't mean it's false. So even though from the perspective of Newtonian metaphysics, the Einsteinian metaphysics doesn't make any sense, it's trying to tell you, but that doesn't mean it's false. And it says, it may feel nonsensical, but relativity has withstood over a century of precise experimental confirmation, and that's GPS, time dilation, gravitational lenses, etc. And it's replaced Newtonian metaphysics not by whim but by necessity to match reality. Einstein essentially said, if nature violates our metaphysical expectations, revise your metaphysics, not nature. And that is not something that's not really something that Einstein said, and said instead AI is placing an interpretation on what Einstein is doing and saying that Einstein should be interpreted as saying that change your metaphysics. And that's nowhere have I read that anywhere, that Einstein's relativity requires you to change your metaphysics as per what Einstein was saying. And so next I shall point out, as dealt with in previous talks, the supposed experimental evidence is being misrepresented. So I've gone into a lot of detail about these other things. You have particularly GPS engineer Ron Hatch, who's pointed out that Einstein's relativity is not really used by GPS. And so all these claims for experimental confirmation of Einstein's relativity are dubious. They're just something that they say, and it's sort of like there's no backup really. They're just saying that these experiments confirm the Einstein's relativity when we've got evidence that they don't. The experimental evidence is being misrepresented by these believers in relativity. And these believers in relativity what they want to do is interpret experiments from a nonsensical point of view, which would make better sense from a Newtonian view. So the experiments would make better sense if you were going from Newtonian metaphysics. AI goes on options for those who resist the shift, that is, those who resist changing from Newtonian metaphysics to Einsteinian metaphysics. And so if you are a Newtonian metaphysician, if you find relativity's metaphysics unpalatable, there are alternatives. And it says it's the Lorentz ether theory, and we've had several talks upon the Lorentz ether theory, and that keeps absolute space and time and reinterprets relativity as mere appearance. And then what other thing you have is the neo-Lorentzian relativity, neo as in you, which is like an extension of the Lorentzian relativity idea. In that one maintains the preferred frame hidden by observational symmetry. And the idea philosophical presentism tries to reinterpret relativity in a way that preserves the real present. But these cost you physical simplicity and symmetry, and are less favoured by mainstream physics. So if you don't like Einsteinian metaphysics, you can still stick with Newtonian metaphysics, but just that the mainstream have decided not to do that, and they decided to go with the Einsteinian metaphysics. So what I say is, so can resist the shift, but mainstream physics is firmly embedded in Einsteinian metaphysics and will ignore your resistance, not even acknowledging it in the physics education system, with it deemed as not being physics. So they're going to omit people who complain about Einstein's Einsteinian metaphysics. They're just not going to mention the subject. But getting on to Einsteinian physics, the physics education system usually starts from Newtonian metaphysics. So they should really acknowledge the shift in the metaphysics when they get to Einstein, but they don't, because it opens a can of worms. If they suddenly open this can of worms and admit there's a metaphysical change happening as you go from Newton to Einstein, well, the students are going to start having critical thinking, and they can start questioning more what's being taught to them. Hence why it's being missed out, because they want to brainwash the students with believing Einstein's relativity. And it's this shift that causes most of the problems. If you're comfortable in Newtonian metaphysics, then this shift to Einsteinian metaphysics makes no sense. And the response from the physics community is they're just going to ignore that. All these people, such as ourselves, the distance who many of us are working from Newtonian physics with its metaphysics, well, they're just going to ignore that. Our problems with dealing with the shift and saying it doesn't make any sense, well, they're not going to respond to that. They're just going to pretend it doesn't exist. They're just going to label it as whatever geography term they can think of. So, back here. So that's the end of my little rant and rave and criticism of Einstein's relativity, this time from the metaphysics. Okay, anybody want to put their hand up? No, right. No. Can open it up to debate now. So, if I look in the comments, if you can write my name at the beginning, so I know you're referring to me, because what happens, you just start having conversations among yourselves in the comments. So good morning, everybody in the comments. So Shockwave says, until we actually do the measurements at relativistic speeds, none of the metaphysics of relativity being talked about can be resolved. I don't think so. The metaphysics is determining how the experiments are being interpreted. So what else we got? So this one. So this person says, it's odd we are in a position of having a mathematical theory and we're left interpreting what the mathematics means rather than a philosophical theory and develop mathematical tools to work within it. Well, as I try to point out, it's not being explicitly stated what the philosophy, which is the metaphysics of relativity, is. It's not being properly stated, and it's why is there sort of supposed to be a change from the Newtonian point of view to the Einsteinian point of view? It's not being pointed out as to why such a thing is necessary. So my glass of water. Says there are several experimental results that does not agree with special relativity results. Aberration with double stars, transverse Doppler effect, etc. And my point on that is, if you, unfortunately, when you go with Einsteinian physics, you are then adopting Einsteinian metaphysics, and so you are still then trying to fit everything into that Einsteinian metaphysics. So you may do experiments which have problems with fitting into Einsteinian physics, but you'll still be trying to fit it into the Einsteinian metaphysics. Next. So, come on, show. Okay, so this person says the universe is still sadly misunderstood. There's redshift that needs fixing. There is the electric nature of the universe that's starting to show itself in papers, and much more wrong with cosmology. Yeah, but it's my arguing problems here is that there's still all those sort of things are still trying to be understood from Einsteinian metaphysics. So this person points out the problem is not the experiments. Whatever experiments are done, relativists will always support special relativity. And what they're actually doing, those relativists are actually doing, is supporting the Einsteinian metaphysics. So they will try to amend special relativity if needed to still fit with any experiment based upon that metaphysics. It's going down. So a lot of comments here about GPS. Not actually talking about GPS specifically. GPS was dealt with a lot more by Ron Hatch. So, what metaphysics is Roger talking about? I thought I explained it. The Newtonian metaphysics was contrasted with the Einsteinian metaphysics. So most of the comments are private conversations among themselves. So I think I've dealt with the comments, and there's some more turning up. Has anybody got a hand that can put their hand up? Right. Anybody in agreement? Oh, I got a hand, right. Add to the stage. Hello. Yes.
Hi, Roger.
Hello, James.
I found this a very interesting presentation that you put together, man.
Thank you.
Summarizing some very basic ideas in a clear way, and I thank you for that. And
Thank you.
I'm coming up with sort of an absurd summary of the whole message here. Maybe the only way to, if data is illogical and does not make sense, it confirms special relativity. How's that for a proposition?
I think quite good.
I've stumped you.
Yeah, try again. If
well, okay, let's invert it. Instead of confirming special relativity by data which is illogical and nonsensical, we can falsify special relativity by showing data that does make sense and is logical. Basically, you're saying that if the metaphysics of relativity, special relativity, and I guess you threw in GR also, is nonsense, the way to confirm special relativity is to show that the data is nonsensical.
I think
I'm agreeing with you basically, and just phrasing it in an extreme manner. I'm not trying to stop you.
I'm thinking the interpretation of the data is nonsensical. It needs the interpretation needs to be from Newtonian.
Okay, that's a good clarification. I'll go with that.
Yeah.
Okay.
But they're interpreting it from Einsteinian metaphysics, and from a Newtonian metaphysics point of view, Einsteinian metaphysics doesn't make any sense.
And all of the, as far as I know, or can gather at the moment, all of the so-called experimental confirmations of special relativity have alternative explanations. And so therefore, we're left with a theory that has no definitive affirmation as far as observation goes. Does that make sense to you?
Yeah. That's there are different ways of interpreting the experiments, and so when I was only contrasting the metaphysics of Newtonian versus Einsteinian, and at the moment they're locked into interpreting it from the Einsteinian point of view rather than from an alternative theory.
Well, take for example gravitational lensing. Actually, you can leave out the word gravitational because in my view anyway, around a massive object like a star, there is a lot of energy, which is something, in that space. And so it's just simply a case of lensing, just like you can have the lens in your eye or any other object through which light travels and is going to be bent by the trajectory apparently bent by the presence of this material. Has nothing to do with gravitation. It's just the presence of material through which light travels.
Yeah, I think that was Dowdy's point of view.
Okay, so it's my point of view also.
So Dowdy, sort of a NASA scientist who sadly passed away, and he thought it wasn't gravity. It was a bending of light through sort of like a fractive medium. So you've got a big halo of gas, plasma around the sun, and sort of like light going through it, it would be bent just from
So
that.
of
Like
the
a normal
three
lens.
things that AI mentioned, which was the, let's see, the GPS and the gravitational lensing, we've eliminated the first two. The third
Yeah,
one was time dilation.
yeah,
Um, I'm not sure exactly what experimental evidence actually definitively establishes that time dilation actually occurs. And by the way, why would it only be time dilation? Why not time? What's the opposite of dilation? Contraction.
stretching, contraction. Yeah, yeah. Time
Uh,
stretching, time
you know,
contraction.
why is it only one way and not the other?
Yeah,
Uh, is there any definitive evidence on that? I'm not trying to put you, Roger, on the spot, but perhaps
yeah.
anybody
I,
here
I,
might chime in to
I,
educate me as to what exactly this evidence is that people
well,
purport to support special relativity. Okay, thank you.
I, yeah, I think for fiddling around with the maths, which I did last time, I think what most of it is hidden away because rather interpreting light speed changing, you're trying to interpret light speed as constant, and then it's the time changing. So it's just a fiddle around the mathematics. They
Oh,
don't
I
want to.
see. So, in other words,
Yeah,
according to your analysis there, that yes, I recall you talking about that,
yeah.
and others as well, by the way.
Where they
That's not
fiddle around with.
definitive evidence in my mind.
Yeah,
I mean, gee whiz, So the bottom line is that special relativity doesn't seem to have any evidence supporting it that is definitively and uniquely indicating that special relativity is the only
yeah.
explanation for the phenomena observed.
Exactly. You can have other theories, as I pointed out in those slides. You've got the Lorentz theory, and then you've got the extended Lorentz theory, which is neo-Lorentzian theory. So you can start trying to interpret experiments from different theories, and that's not what they're addressing when they're teaching physics students. Say you go on a physics education system and you want to be taught Einstein's relativity, then they teach you Einstein's relativity and they don't tell you, well, maybe the experiments can be interpreted by different theories. They miss that out as well. So
Good
miss
point.
that. They miss all that out. They just they. I've gone on these courses where they teach adults and so forth, and I've talked to the lecturer or teacher or professor and said, why you mention these other theories? And they said, well, I'm being paid to teach Einstein's relativity in this course. I'm not being paid to teach the other theories. So they're missing out all of that. They're only just concentrating on Einstein's relativity and teaching that. And, and they're teaching the physics, so they're missing out the metaphysics. They're just missing it all out. It's sort of like it's all been dumbed down. It's sort of like, and as I pointed out, when the physicists do look at the metaphysics, they don't agree. When they look at the metaphysics, Einsteinian metaphysics, they don't agree what that means in terms of the mathematics, and so they miss all that out as well. So all the disagreement between the people who believe in Einstein's relativity miss it out. Just keep missing it out. They don't even mention it. So they should at least mention, oh, I'm teaching you Einstein's relativity, but I'm telling you what it means. But other people don't necessarily agree with me as to what that means. They're not even mentioning that. It's like just teaching you, this is the dogma, you believe this. This is and you've got to write this answer for the exam.
Yeah, it sounds like you're describing a situation that may be subject to a complete collapse at some point.
What you should do.
Like there's a lot of talk in the political sphere of various governments or financial systems that might suddenly collapse.
Yeah.
In this science and physics sphere, it
Yeah.
sounds like we have almost a perfect analogy that this whole system might collapse.
We might. It's because
One,
yeah. Yeah.
go ahead, Roger.
Yes, that's right. The whole thing might collapse one day because it's sort of like they've built all this thing up, and they're not allowing critical thinking to come in on it.
Exactly. My last point, if I may, is that in a previous comment that you had up on the screen, a Kurt Renshaw, Renshaw,
Oh yeah.
wanted a different metaphysics, if you will, and then developing the math and rules and laws of physics, if you will, based upon that different metaphysical approach. And I just like to point out, toot my own horn, if you will, that binary mechanics does that precisely. It has a completely different metaphysics in terms of full quantization. I won't get into a whole lecture on it, but I just wanted to point out that that Kurt Renshaw wants binary mechanics or something like it, apparently. Thank you.
Yeah. Okay.
Good
Thank you.
Rob. Good
Okay.
show.
Thank you. I'm criticizing relativity mainly rather than look at other theories. And the main problem is the jump from Newton to Einstein. Okay. Thank you. I've got another hand now up. Thank you. Okay. So next hand. Okay. Hi, Dennis.
Hi, Roger.
Hey,
There is a lot of data, gravitational data. It's in this book by A.L. Dmitriev. He's a Russian physicist.
Oh, yeah.
And this book was 2018, so it's getting to be a little dated now. And he's done similar research later on. And all this data shows that it deals with things called like levitation and the temperature dependence of an object on its gravitational pull. He shows that if you measure things carefully enough, you can see that as the temperature changes, the gravitational pull towards the Earth changes too.
Yeah.
And he also talks about levitation. If you take a rotor, a cylindrical rotor, and spin it at a high angular velocity, where the about the axis of symmetry, which is assumed to be horizontal, not vertical, then you get what he calls levitation. You get the thing becomes lighter.
Yeah.
And I pointed out, I tried to explain this in my book with Jeremy Dunning-Davis, Newtonian Mechanics with Extension of Relative Velocity, Part 1, that this can be explained by assuming not that gravity becomes weaker, but that inertial mass under a rotation like that becomes stronger. And so the inertial mass is resistance to pull. So if the inertial mass of this rotor that was spinning horizontally increases, its resistance to the pull of gravity will increase too, and consequently it'll appear to be lighter, less, way less. And he has a lot of data on that sort of thing too. And he's getting exactly nowhere. Every time he proposes an experiment to the Russian government that would test his theories versus the Einstein's theories, they refuse to put it on their agenda for a space probe. Of course, in outer space, you can there's less problems with measurement, and so you can get better data. But they won't. Apparently, it boils down to this: if he is right all their theories go down in flames if the experiment shows that he is right in outer space. Whereas if it shows that he is wrong, then the status quo remains. So on one hand, you lose everything. On the other hand, you don't gain hardly anything at all because it's just one more experiment that failed to show that Einstein's special and general relativity theories are wrong. So it's his chances of getting this Russian space probe experiment through the Russian physicists who run the thing are zero, apparently. And it's unfortunate, of course, but it's much the same in the Western world. And around in the United States, for example, they do not, as you pointed out many different times, they're not interested in showing that special relativity is wrong. Even though AI will admit that Ron Hatch's theories, which give much better, almost perfect results, he uses the fact that the Earth is spinning in a certain direction, which shouldn't matter according to special relativity, because any inertial system will do. And the AI admits this, but they say they refuse to take a logical conclusion that special relativity is wrong. And I talked a little bit about this on earlier meeting towards the end when it was run by Franklin Hu, and
Yeah.
I was just getting to the interesting part when time ran out.
Yeah.
But you can go to AI, you can use AI for free. I open Acres AI, and
Yeah.
it will admit that Hatch used the fact that the Earth was turning, whereas special relativity people don't do that.
I am. Okay. Yeah. So AI is interesting because you can ask it the questions which seem unanswered by people who believe in relativity. So
Yeah, it basically follows their principles, but unlike them, it wants to help you understand. It wants to make you understand. Whereas they are not interested in making you understand. They want interested in shutting you up.
Yeah. It's unfortunate AI can't be taken as gospel on relativity, though, but it does give interesting insights into relativity.
Yeah.
And what you're saying about the rotating thing, that sounds similar to Lathwaite. Lathwaite, a long time back, was saying about uh, gravity being affected by you have some things spinning, and you put it on a scale and weigh it, and it's sort of the weight decreases.
Levitation, he calls it.
Yeah, Lathwaite. Do you remember Lathwaite?
Eric Lathwaite?
Lathwaite. There's a person called Lathwaite.
Lightweight?
Laithh. I think it was an EWAITE. If I can.
I haven't heard that before. I haven't run across that.
You haven't heard of Lathwaite? Let's see if I can get him.
Well, how would you define it?
Sorry. I think it's Lathwaite, anti-gravity. He gave talks at Christmas.
Oh, yeah. Eric Lathwaite.
Eric Lathwaite.
To the Royal Society, the children.
Yeah.
He also realized that
if I can show
that gravitational pull on objects depended on gyroscopic properties.
Yeah.
And a guy by the name of Waite, can't think of his first name, has an article where he shows both experimentally and theoretically that under certain circumstances, the rotating gyroscope loses weight.
Yeah.
But the thing is about my theory.
Showed it there. This Lathwaite. There's a video of his Eric Lathwaite's. I can't read it because it's too small on my side. There's a lecture he gave. It's 1974 lecture on gyroscopes, and he was talking about there being an anti-gravity effect.
Yes,
and he was attacked for that.
Yes,
mainstream.
They actually claimed that he was in league with the devil.
God.
Really? You can find, and they used to be able to find things on the internet about that, but I think they pulled them all down and they realized that's not good.
Yeah. But so the mathematics for gyroscopes is very complicated.
Yes.
And so from the mainstream point of view, they were saying, oh, we can understand gyroscopes, but when you look into what they're talking about with their mathematics, it's very complicated. And so Lathwaite was coming along saying, no, with this gyroscope, spin it and it loses its weight. There's anti-gravity going on. And so it was a much more simplistic way of looking at it. And I looked at it and tried to make sense of it, and I've become unstuck, afraid.
In Jeremy and I's book, we showed that the loss of weight depended in part on the acceleration of the object. The loss of inertia, the gain of inertial mass, which results in a loss of weight. The gain in inertial mass depended on the acceleration. Well, if you take an electron, the acceleration of electron under a field of force, electrostatic force, is inversely proportional to the mass. But if the mass is almost zero, the inverse of almost zero is almost infinity.
Mm-hmm.
So you would expect that electrons would show much different behavior under acceleration than heavier particles like protons and atoms and whatnot. And it turns out to be true because in a book with, what's his name? Maybe I can. This book, Newtonian Electrodynamics by Peter and Neil Grant, father and son. They showed that by experiment that what they called an electromagnetic pendulum.
Unfortunately, I can't see it very well.
How's that?
I can't see very well. I see if I move myself.
Newtonian electrodynamics.
Okay.
And
the
experiment. There were two experiments. One was an exploding wire experiment, and the other was a electromagnetic pendulum experiment.
Yeah.
And both showed forces that were at least 1,000 times larger than predicted by classical electrodynamics. And they couldn't explain it, but Jeremy and I's book explains it in terms of the fact that electrons are extremely small mass, and so the acceleration that they feel under a field of force would be almost infinite, and hence the slight levitation experienced by rotors would be magnified many times because of the fact that the electrons had so little mass, and so the acceleration was so huge. And so the exploding wires could be explained by the electrons in the wire lattice gaining huge percentages of inertial mass and crashing into the lattice and fracturing it. And the electromagnetic pendulum experiments that they did, where the effect was 2,000 times, or 1,000, at least 1,000 times larger than predicted by classical electrodynamics. Those experiments were explained by the fact that what was causing this electromagnetic pendulum to jump was the huge mass of the electrons under tremendous acceleration crashing into the end of the pendulum device and causing it to swing way up. And of course, when your pendulum swings up, you know just how much energy was delivered to it because of classical mechanics. So there's no question, but the whole system, as you point out, and as James Keene pointed out, it could collapse. It certainly could. But the problem, what keeps it from collapsing, is the fact that although special relativity is wrong, it's very useful in a lot of cases. And and also general relativity has been used for people who make, a man who makes electron microscopes. So as long as it's useful, it's very difficult to make the system crash.
Yeah, they think it's useful. When they got problems with dark energy and dark matter, they're trying to add something extra to it. That's the problem.
Well, the electron microscopes, though, aren't like that. Electron microscopes either work or they don't.
Yeah.
You know, I mean, you can't say, well, that's just the hocus pocus. If some guy's building a better electron microscope using special and general relativity, as this, I can't think of his name, an Australian fellow, Vivian Robinson. He makes, and he sells them because they work.
Mm-hmm.
You know, it's not like dark matter, you know. I don't know if you know it or not, but David D. Hilster has a short video on.
I know. Yeah. I know.
On dark matter, and shows that dark matter only appears in disk-shaped galaxies, and the reason that it seems to appear is the fact that they can measure, and they see that the outer stars in the galaxy are moving at either too fast or too slow. I can't remember which. I think.
Yeah, I know this video. I've seen it. Yeah. It's something else that the mainstream seem to ignore, that issue.
Yeah, they say that they compute the gravitational field of a lens-shaped galaxy.
Yeah.
Using the assumption that all the mass is concentrated at the center, just like if it was a spherical galaxy.
Yeah.
But it's not. I mean, you don't get the right answer if you do that.
Yeah.
Terrible. But Vivian Robinson's electron microscopes work, and there's no hocus pocus like that.
Okay. So eventually it's going to have to change to another theory, I think. They've got problems combining relativity to quantum physics, so they're going to have to show you something.
There's an infinite number of paradoxes coming out of special relativity, and because of the fact that they don't agree that time travels uniformly throughout the universe. And they say it runs faster here and slower there and so on. But actually, it's the cesium clocks that they use to measure it that run slower or faster in a gravitational field or at a high velocity. And so, since they've got metaphysics wrong, there's so many paradoxes that you can't even add them all up. Each one is explained by some hocus pocus type explanation.
Yeah. I think we've had talks complaining about the twin paradox and what is supposed to be the one explanation for it, because they don't. If you ask people in relativity what's the explanation for the twin paradox, they often come up with lots of different explanations for it. And really, if you had a proper theory, you would just have one explanation. So, but they don't see it that way. So,
in one of my physics books that I got from one of my sons when he exited the course at the University of Michigan, it explains the twin paradox in terms of the fact that one system is accelerated and the other is not.
What system is what? Sorry.
What?
Sorry. Could you repeat that, please? One system is
accelerated because one of the twins goes out and then comes back. He's accelerated. The other does not. That's how they explain why it's different. But that doesn't work either, because both of them could be accelerated, and you would still, according to special relativity, get the difference in as long as they weren't accelerated at the same rate, you would get a difference.
There's a lot of disagreement in the twin paradox, because sometimes people say, you can deal with it just within the context of special relativity, and other people say, no, you've got to go to general relativity. And then some people say, special relativity can't deal with acceleration, and then other people say, it can. And so it's sort of, everything ends up with a confusion of people saying lots of different things. Hence, this ends up with lots of people saying different things for the twin paradoxes. The theory, the whole thing of special relativity and general relativity from Einstein is a bit of a mess.
Terrible.
Yeah. So today I was just pointing out the metaphysics. It doesn't make sense to change from the metaphysics of Newtonian physics to Einsteinian physics. The change in metaphysics doesn't make sense, and they're not telling physics students that. If they tell physics students that, then they sort of might cotton on that things don't make sense. At the moment, they're just going on to these relativity courses, and they're trying to understand what's being taught to them without it being explicitly stated to them the problems in the metaphysics. And so, student, if he tries to understand Einstein's relativity and he fails, they then sort of put it on themselves. I'm not clever enough to understand it, and they might drop out of the course. While those who persevere and manage to answer all the questions in the exam and pass, they think, I understand it, but they don't. They haven't addressed the problem areas in Einstein's relativity. They've just glossed over it. They've skimmed over it.
Yeah.
They haven't been subjected to the problems. So it's kind of like they kind of got a mental block on things, and then people who are working from the Einsteinian metaphysics, and if they believe it, they don't understand the problems that people have with Einstein's relativity who are working from the Newtonian metaphysics. So it's nobody can communicate properly with each other because the whole thing's not being taught properly.
No.
The students should be introduced to critical thinking, and then they can start arguing with the teacher and saying this doesn't make sense. But that's the way that they've done physics. Yep. And you got all these other issues, like you pointed out, with the Lathwaite and that. Well, people who are locked into believing the Einsteinian stuff, well, they got a closed mind to things like that. And if they're controlling research councils, then they're not going to there'll be funding for experiments like. Sorry?
There's power and money.
Yeah.
Involved.
Yeah. Yeah.
And as long as special relativity and general relativity are being used by people who do things that are not hocus pocus, there's a little chance that things will change because if anyone wants to do an experiment that might show clearly that there's something wrong, they basically don't allow it, and that's it. That's why Dmitriev hasn't succeeded in convincing people.
Can you hold on a minute? I'll make you full screen, and you put the book up.
Partly in Russian, but mostly in English.
Okay, thank you. Okay.
Physical Gravity is the title, and he called it that because general relativity is mathematical gravity. The only tie-in between general relativity and physics is that it's assumed to equal Newton's theory at first order.
Yeah. I can't remember. I've done properly criticism of general relativity, but when you deal with Newtonian gravitational theory, there needs to be a tidal force added to it, and then the theory becomes called Newtonian tidal gravity theory. And so when they talk about the general relativity, what they've got is both a Newtonian gravitational force and a Newtonian tidal force. And they don't talk about things properly then. They're sort of like comparing general relativity that's got both a tidal force and a gravitational force. And they're comparing it just to the Newtonian gravitational theory, and they're not comparing it to the Newtonian tidal gravitational theory. So that's how they mess it up from that direction.
Well, there's a book out. There's a book out by André Assis, who's a professor in Brazil.
Yeah.
And there's two editions. The title of the book is Relational Mechanics. And he compares Newton's theory of physics, mechanics, and gravity with Mach's theory, a Machian theory, which uses not gravity, but uses Weber's gravitation, Weber in the 19th century. And this thing is huge. I mean, the second edition is like a telephone, like it used to be in the old days, a telephone directory in a large city.
Yeah.
It's huge. And I don't think he's ever gotten very far with that. Not necessarily because it gives the wrong answer, but because classical mechanics is so useful. Here again, usefulness trumps everything. Because the students, when they come out of the physics college with a physics major, want to be hired, and they wouldn't be hired if the material they learned, however wrong it was, were not useful. The people who hire these people don't care if Newton's theory is right or wrong, or what. They just want somebody who can build things that work.
Yeah.
And of course, when if you're a mechanical engineer, you come out of a good school with mechanical engineering, you can get a job. Assuming that the whole world economy doesn't crash someday. But at the moment, you can get a job. I have a grandson who's studying at the University of Michigan. First he was a mechanical engineer, now he's an industrial engineer. He switched. But he doesn't gonna have any trouble getting a job, even if he had stayed as a mechanical engineer, because they need good mechanical engineers. Mechanical engineering is complicated, and to build devices, some of these devices with all these moving parts and everything, is not an easy job.
Yeah.
And so it's utility that rules, not correctness. They don't care how wrong it is. The people that hire these students coming out of college with the physics or mechanical engineering or electrical engineering degree, all they care about is can they take a problem and solve it? Can they build a device to meet the specs or not? They couldn't give a damn whether they're wrong, as long as it's useful.
Yeah. Yeah. Okay. Sorry. Oh. Okay, thank you. Cheers. Yeah, so it's going to take a lot before things start changing.
Yeah.
Okay. I think that's it then, really. I don't see any more hands. So if you finished, do you got any more to say?
Thanks.
Okay. Thank you. You finished. Okay. I will take you down then. All right, great. Thank you. Thank you, Dennis, and thank you, James. Okay. So back to full to me. So summarizing it up. So the metaphysics of Einstein's relativity doesn't really make sense, and they've managed to gloss over that. So it's another criticism of Einstein's relativity. And if they were to address that properly in a physics course teaching physics students, then that would probably cause a lot of debate, which they don't want, because a lot of things are not agreed in that metaphysics. So that's, I think, summarizes it. So thank you. I think there's no more here. No more hands coming up. Great. So I don't think there's any comments relevant in the. No, I don't think so. So I can finish. I'll finish this session and come back to you with more criticisms, probably of Einstein's relativity next time, from a different perspective. So thank you. Good night, everybody. Pleasant dreams. Right, we got. Bye. Bye.